September 1943. Mud clings to everything in southern Italy. Major Edwin Seibert stands in a field hospital tent near Salerno, watching medics treat another company of infantrymen. He is a United States Army quartermaster officer. The men before him cannot walk. Their feet are swollen, blistered, infected. Some will lose toes. None of this came from enemy fire. Seibert picks up a discarded boot from the pile outside the tent. The leather sole has separated completely from the upper. Stitching hangs in loose threads. The interior is black with mold. This boot lasted 3 weeks. Standard issue was supposed to last 6 months. Across North Africa and now Italy, entire infantry companies are immobilized not by German guns but by their own footwear. The problem is clear to Seibert. Traditional boot construction uses waxed thread to stitch leather soles to leather uppers. In the constant moisture of Mediterranean winters and spring campaigns, the thread rots. Water seeps through the stitching holes. The leather sole absorbs moisture, becomes soft, tears away. Soldiers march through mud, cross rivers, sleep in wet foxholes. Their boots fail. Their feet fail. The infantry stops moving. Seibert has been a quartermaster for 12 years. He knows supply chains, production capacity, material science. He also knows that wars are won by soldiers who can walk. Tanks need fuel. Artillery needs shells. But infantry needs feet. Without functioning boots, the best trained army in the world cannot advance. He returns to his headquarters in Naples and begins drafting specifications for a new boot design. The solution must eliminate stitching at the sole junction. It must resist water penetration. It must be producible in massive quantities using existing industrial capacity. Seibert focuses on vulcanized rubber, the material used in vehicle tires. Rubber does not rot. Rubber can be bonded directly to leather through heat and chemical adhesion. No stitching means no weak points for water entry. By October 1943, Seibert has a prototype. The design features a treated leather upper and a vulcanized rubber sole bonded directly to the leather through a heat press process. The bond is continuous, waterproof, flexible. He tests it himself, wearing the prototype through mud, streams, and rocky terrain for 2 weeks. The sole holds. The bond does not separate. His feet stay dry. Seibert takes his prototype to the Quartermaster General's office in Washington. He needs approval to convert civilian tire factories into boot production facilities. This is not a small request. Tire production supports the entire mechanized war effort. Diverting rubber and factory capacity means fewer tires for trucks, jeeps, and aircraft. But Seibert has numbers. In the 5th Army alone, over 8,000 men are non-combat casualties from foot injuries in the past month. That is the equivalent of an entire division unable to fight. The Quartermaster General approves the program on the 15th of October, 1943. Seibert has 6 months to deliver 2 million pairs of boots to frontline units in Italy. He begins immediately. The first challenge is production. Tire factories use rubber workers, not cobblers. The skills are different. Seibert establishes training programs at converted facilities in Ohio, Pennsylvania, and Massachusetts. Rubber workers learn to cut leather, treat it with waterproofing compounds, and operate heat presses that bond rubber to leather. The process must be precise. Too much heat damages the leather. Too little heat creates weak bonds. Seibert sets quality standards and inspection protocols. Every boot is tested before shipping. The second challenge is materials. Treated leather requires chromium salts for waterproofing. Chromium is also needed for steel production and aircraft manufacturing. Seibert negotiates with the War Production Board for dedicated chromium allocations. He argues that immobilized infantry costs more than the chromium needed to keep them mobile. The board agrees. Chromium shipments are redirected to boot production. By December 1943, the first production run is complete. 50,000 pairs shipped to Italy aboard cargo vessels that also carry ammunition and rations. Seibert travels with the shipment. He wants to observe the boots in actual combat conditions. He wants to see if his design works when soldiers depend on it. The boots arrive at supply depots behind the winter line in early January 1944. Seibert watches as quartermasters distribute them to infantry companies preparing for the Anzio landings. The soldiers are skeptical. They have worn through too many pairs of standard-issue boots. They do not trust new equipment. Seibert does not argue. He knows the boots will prove themselves or they will not. The Anzio landings begin on the 22nd of January, 1944. Infantry companies wade ashore through surf and cross muddy fields under German artillery fire. They dig foxholes in wet ground. They patrol through marshes. They march through rain. Seibert waits at the beachhead supply depot, tracking reports from battalion quartermasters. After 2 weeks, the reports come in. The boots are holding. Soles are not separating. Stitching is not failing because there is no stitching to fail. Soldiers are reporting dry feet even after days in wet conditions. Trench foot cases are declining. Infantry companies are maintaining mobility. The design works. Seibert cables Washington with the results. Production is increased. By March 1944, over 500,000 pairs have reached Italy. By May, as Allied forces break through the Gustav Line and advance toward Rome, over 1 million pairs are in the field. Soldiers begin calling them Seibert boots, though official designation is Combat Service Boot, Type 2. The impact is measurable. In the Fifth Army, non-combat foot casualties dropped by 60% between January and June 1944. Infantry companies maintain operational strength longer. Divisions can sustain offensive operations without losing combat power to foot injuries. The advance up the Italian peninsula accelerates, but production challenges continue. Rubber supplies are still constrained. Seibert establishes field repair depots behind advancing lines. These depots are staffed by cobblers and rubber workers who can replace worn soles, rebond separated sections, and salvage damaged boots. The repair program extends the service life of each pair and reduces demand for new production. It also keeps soldiers in boots that are already broken in, which reduces blister rates. By June 1944, as Allied forces enter Rome, over 1.5 million pairs of Seibert's boots are in service across the Mediterranean theater. The design is also being adopted for production in England to supply forces in northwest Europe. Tire factories in Britain begin converting to boot production using Seibert specifications. The German army notices. Intelligence reports recovered from captured documents mention Allied soldiers with superior footwear that maintains effectiveness in wet conditions. German boot production still relies on traditional stitched construction. Their soldiers suffer the same problems American forces faced in 1943. This is a small advantage, but in sustained infantry operations, small advantages accumulate. Seibert continues refining the design throughout 1944. He adds reinforced toe caps for rocky terrain. He adjusts the rubber compound for better traction on steep slopes. He works with medical officers to study foot injuries and identify remaining weak points in the design. Each improvement is incorporated into production and distributed to field repair depots as retrofit kits. By September 1944, 1 year after Seibert stood in that field hospital tent near Salerno, over 2 million pairs of his boots are in service. The design has become standard issue for all infantry units in the European theater. Soldiers who fought through North Africa and Sicily in failing boots are now advancing through northern Italy and France in footwear that lasts months instead of weeks. The impact extends beyond mobility. Dry feet mean fewer infections. Fewer infections mean fewer medical evacuations. Fewer evacuations mean more soldiers stay with their units. Unit cohesion improves. Experienced soldiers remain in combat longer. The cumulative effect is an infantry force that maintains strength and effectiveness through sustained operations. Seibert is promoted to lieutenant colonel in October 1944. He is assigned to the Quartermaster General's staff to oversee all footwear production for the Army. His methods are applied to other equipment: cold weather boots for the Ardennes, jungle boots for the Pacific, specialized footwear for mountain troops. The principle remains the same: eliminate weak points, use materials that resist environmental degradation, test in actual conditions, produce in quantity. The war in Europe ends in May 1945. By then, over 4 million pairs of Seibert's boots have been produced. Post-war analysis by the Army's Quartermaster Corps calculates that the boot program reduced non-combat foot casualties by approximately 70,000 men over the course of the Italian and Northwest Europe campaigns. That is equivalent to keeping 4 infantry divisions in the field. Seibert's design remains in production after the war. The Korean War, fought in mud and mountains, proves the design's continued value. Modifications are made for tropical conditions, Arctic conditions, desert conditions, but the core principle endures. Vulcanized rubber bonded to treated leather, no stitching at the sole junction, waterproof, durable, repairable. Seibert retires from the Army in 1952 as a full colonel. He does not write memoirs. He does not seek recognition. He returns to civilian life and works as a consultant for footwear manufacturers. His contribution is recorded in Quartermaster Corps histories and technical manuals, but his name fades from public memory. What remains is the lesson he proved in the mud of Italy. Wars are fought with firepower and strategy, but they are won by soldiers who can walk. Equipment that fails in the field costs lives and loses battles. Innovation in logistics is as vital as innovation in weapons. A functioning boot is as important as a functioning rifle. The boots Seibert designed kept soldiers mobile through 2 years of combat in Italy. They carried infantry companies from Salerno to the Gothic line, through mud and mountains and winter cold. They proved that attention to basic needs, to the practical details of keeping soldiers fed and clothed and mobile, determines the outcome of campaigns as much as tactical brilliance or superior firepower. Seibert understood this. He saw the problem clearly. He engineered a solution. He drove production and distribution with the urgency the problem demanded. He measured results and refined the design. He did not wait for perfect conditions or unlimited resources. He worked with what was available and made it enough. The field hospital tent near Salerno, where Seibert first saw the cost of failed footwear, was eventually dismantled and moved north as the front advanced. The soldiers treated there recovered and returned to their units, most of them wearing the boots Seibert designed. They walked through the rest of the war. That was the point. That was the victory. Not dramatic, not celebrated, but absolutely essential. Wars are won on soldiers' feet as much as firepower. Seibert made sure those feet could keep walking.